Okay, this video is going to show you how to go from mass of one substance all the way to mass of another substance. And in my opinion, this is the hardest type of stoic problem that you can do because it has the most fractions and the most calculations. It is likely that there will be problems like this on your test because if you can master this problem, you've mastered a stoic. So here's the formula that you will have. There will be a very similar formula to this on your formula sheet. So just pay attention to that. Okay, so here's an example problem. We have an equation. We need to make sure it's balanced. So if I have 2 nitrogens on the left and 1 on the right, I need to go ahead and multiply this guy by 2 to make them even. And now I have 6 total hydrogens over here, but only 2 on the left. So I'm going to go ahead and multiply this guy by 3 to make it 6. So there we have a balanced equation. Okay, now I need to make sure I underline my given, and then I circle my wanted. Okay, and my first fraction in stoic is always going to be given over 1. So I'm going to say 50.0 grams of nitrogen. Okay, be careful. A lot of people I've seen, when they see the word nitrogen, they just do this. But really it's asking about diatomic nitrogen, because when nitrogen is by itself, it's with its twin. So don't mess that up for yourself because it will really mess up your conversions. You can only ever do this math based on who's in the equation. So if you never see a plain N by itself, you know you can't be doing the math for that. You have to use one of the reactants or products from your equation. Okay, so directly diagonal, you're going to do the same unit and the same substance. Get into that habit. Get into it now so that you don't mess yourself up later. So if we start with grams, the only conversion we know is from grams to moles. We don't know a direct conversion between grams and liters or grams and particles. So we have to get ourselves to moles because moles gets to translate between everybody. Moles is like that central person in these conversions. So we're going to go ahead and put moles on the top right here, and we're going to put the same substance right there. If you are changing units, you have to keep the same substance. The only time you ever can change substances is when you have moles divided by moles, and I'll show you this later. So we know the relationship between grams and moles. That relationship is called the molar mass. And so the molar mass is going to be whoever you have, so that's nitrogen. There's 2 nitrogens times whatever the periodic table says the mass of nitrogen is, and that's 14.01. So if we have 2 nitrogens, it's going to end up being 28.02 grams for every 1 mole of nitrogen. Okay, and what I'm going to be able to do is I'm going to be able to cross out the same unit and same substance that are diagonal to each other. So we kind of have this big diagonal teal line happening. And now I can move forward because I'm at moles of N2, but I eventually want to get to grams of hydrogen. So directly diagonal, I'm going to put moles of N2. And now that we're at moles, we want to be able to translate between our 2 substances. And the only way you can do that is by using your mole ratio, that guy right here. Okay? You will be given that formula on your test, so just learn how to use the formula if you don't know how to do it just in your head. So we can put moles on top of moles, and if we're trying to change to hydrogen, because we have moles and moles together, now we can change to hydrogen. Okay? And so now when we see moles divided by moles, we know where to find those numbers for the mole ratio. They come from our balanced equation. So the number that's in front of H2 is 3, so we're going to put a big 3 right there. And the number that comes in front of N2, it's blank right there, which technically means it's a 1. Okay, and that's really just saying for every 1 molecule of N2 that we use, we also need to use 3 moles of hydrogen. So I'm going to be able to take a new color, and I'm going to be able to cross out my same unit and substance. And you should be seeing a diagonal pattern happening here. First we have that blue diagonal line, next we have that pink diagonal line. And that indicates to us that as long as we're using the right numbers, we're chilling. Okay, we're at moles of hydrogen now. That's the only unit that's left over. Is that where we want to be? No, it's not. We want to be at grams of hydrogen. So we're halfway there because we're at hydrogen. We're just at moles of hydrogen. So we're probably going to need to do one more fraction. The most types of fractions you're ever going to have, at least in our class at Gilbert, it's going to be four fractions. So We know that we're at the end here. So we're going to put the exact same unit and substance directly diagonal. And now that we're at moles of H2, we can get ourselves to who we want, and that's going to be grams of H2. And we know the relationship between grams and moles ends up being our molar mass. And so we have to go find the molar mass for H2. So that's going to end up being, there are 2 hydrogens, each hydrogen is 1.01 grams, that's going to be 2.02 grams for every 1 mole of hydrogen. Exactly what it says up here in that last fraction. Okay, and I'm going to pick one more color, and I'm going to say, okay, moles of H2, you cancel out with this, moles of H2. See how I'm just crossing out the units and substance and not the number? Those numbers still count, it's just the units that are crossing each other out. So you should be seeing these 3 diagonal colors happening. And we're left with who we wanted, right? Grams of hydrogen, grams of hydrogen. So we can go ahead and solve. So I'm going to go ahead and say 50.0 times 1 times 3 times 2.02 divided by 1 times 28.02 times 1 times 1. And when I put that in my calculator, if I can do it fast enough, I believe this becomes 10.8 grams of hydrogen.